Hi, welcome to Data Affairs with Indro. Today we will be dealing with the topic named as central tendency. This video is on a series which we have started previously on statistics. Let's start the topic. Central tendency. The central tendency basically refers to the measure used to determine the center of the distribution of data. Basically, it determines the center of the distribution of data that we are having, the data set basically. Now see, if we have a data set which I'm naming it as I 1 1 2 2 3 3 4 5 5 6, and I do have another data set F which is 1 1 2 2 3 3 4 5 5 6 100. Now we are supposed to find something. What something we are supposed to find? This central tendency we mainly refer to mean, median and mode. So let's see, if we find out the mean for this above set, what will come out to be x bar. Here what we will do, we will be summing this up, number of data or the samples we have 1 2 3 4 5 6 7 8 9 10. So this would be 10, and the sums up to 1 plus 1 2, and this on addition we will get 32. So we are getting 3.2 as the mean. Now let's find out mean. In this case we are having the identical data set, but we do have another data in another element in the last, that is 100. So we had this data 32 previously plus 100 by, now 10 was the previous data set number count, and we have one more. So this is 132 by 11, which comes out to be 12. So see, here we are having mean of 3.2, and in this particular data set we are having a mean of 12. There we are finding a drastic difference in the mean. Why is it so? Because by our naked eye we can directly say that we are having a difference in between these two data sets, which is an outlier, as we can define it as, and the following element is 100. This 100 data, 100, we are referring it as an outlier. Okay, this 100 is being referred to as outlier. We may define outlier based on our statistical analysis as well as on the demand or the perspective which we have, or on the business requirements we are dealing with. Okay, so if suppose we are having a data set like marks obtained by a student in 5 subjects. Fine. So if we have Hindi, English, Bengali, and there is mathematics and there is science, and we are forming a table. All these are rows and this particular is column, and so we are writing this as marks obtained as if Hindi he has got suppose 65, English he has got 70, Bengali he has got 102, mathematics he has got 95, and science he has got 71. So we are supposed to find out an outlier in this case. So we may say each of these data by, we may use mean something as if mean, and we may also calculate the mean in this case, and then we may also say that where the data is lying, how is the variance upon that, and how is the standard deviation in it. So there will be a statistical concept which we will be dealing in with. But by our naked eye we may say that since this data is a data for the marks obtained by a student, and since the total marks for each subject is supposed to be 100, so none of the subjects in which this particular guy would have got 102. So this particular data is a false data, or has been misinterpreted or mistyped into the data sheet. Therefore 102 may be taken as an outlier in this case. Okay, so it particularly depends on either the statistical concepts that we are taking up, or the demand, or what purpose we are taking into, business demands or business deals that we are taking into. Fine. So but one more thing what we shall be keeping in our mind while having an idea of outliers is that if in a data set, outliers keep on increasing, then distribution, which we will see later on also, normal distribution and various other distributions which we'll be having, but right now we will be seeing only the normal distribution. And if we say that if in a data set outliers keep on increasing, then the distribution tends to become normal in nature, or the distribution attains normalcy. Okay, so and on the previous day we have also, I think this is particularly understandable, and this particular data will be also this particular statement will be also be dealing when we will be learning that normal distribution function, where we'll be taking this 65.6% and that sort of criteria. Standard deviation, 1 standard deviation, 2 standard deviation, 3 standard deviation, we'll be dealing into that. Particularly right now, which I am primarily focused on, is that since I think we have done mean calculation, and the importance of median will be an also important concept that to look after, and I think we have looked, and for this basically I should make a star mark right over here, that for this purpose which we have seen previously on this particular video only, that the mean happens to be 3.2, and in another data set the mean happens to be 12 because of an outlier termed as 100. Therefore we go for median, as if for eliminating errors in central tendency calculation for a data set, eliminating the effect of outliers, we use median as a major prime concept. Okay, now let's understand the concept of percentiles and quartiles. So first of all, let's see percentage. I think we all know how to calculate percentage. If we have a data set 1, 2, 3, 4, 5, now calculate the percentage of numbers that are odd in the above data set. How do we calculate it? Of numbers, the symbol is for numbers, number of numbers that are a count of numbers that are odd by total numbers, which comes out to be how much? I guess, see how many are odd, 1, 2, 3. Therefore 3 by how many are the total numbers? So n is equals to 1, 2, 3, 4, 5. So let's put it up here, 5, and this comes out to be how much? 3 by 5 is equals to 0.6. So 0.6 is equivalent to 60%. I think we know this kind of a data, like 2 by 5 is equals to 40%, 3 by 5 is equals to 60%, 4 by 5 is equals to 80%. This we shall memorize it. Then let's go for the percentile concept too. I think this is visible. Let's move on to the concept of percentile. So the percentage calculation is quite clear, I guess. Next, percentile. So let's have a data set 2 2 3 4 5 5 5 6 7 8 8 8 8 8 9 9 10 11 11 and then there is 12. Fine. So I am having a data which is having elements 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 to 19 20. So n is total number of samples or elements is 20. So now if I am supposed to calculate percentile ranking of 10, so what am I supposed to calculate? Percentile ranking of 10. So let's write down a formula that percentile ranking of x is equals to count of values below x by n, that is total number of samples, into 100. So for this, one thing we must keep in mind that for calculating the percentile we must like in median calculation, we must first rearrange our data. Since my data which I have written it over here, I have rearranged it from ascending to descending order. Here I see the data has been sorted in ascending to descending order, and that's why we may be able to calculate the number of values that are below x, that is in our case x is equals to how much? 10. So let's check where is 10. Here this is 10. So we have 20 numbers in our total as 20 elements in our data set. So if I calculate it 1 2 3 4, so 20 minus 4 is equals to 16. Therefore 16 is the total number of values which are below x. Therefore we may keep as 16, and n which we have total as 20, therefore into 100, which comes out to be 4 4 ja, 4 5 ja, and 5 20. Therefore this comes out to be 80%. And now this 80% is nothing but what we can infer in conclusion, that 80% of entire distribution of the data set, entire distribution of the data set is below 10, is less than 10. Basically we are having 80% of the elements within the data set of total numbers of elements as 20 less than 10. Okay, I think this is visible. Please take a screenshot of this following. Now suppose if I was to calculate the, if my x particularly would have been 11, that is I was to calculate the percentile ranking of 11. Now particularly which 11 should I consider? I am considering this 11, this particular first 11. So if I was to calculate the percentile ranking of 11, what would have been my result? What would have been my percentile ranking? So see now how much this count of values below x would have been how much? For 10 it was 16, so for 11 it would be 17. So see, I'm calculating it right over here. So 17 by total number of values was how much? 20 into 100, so 25. Therefore it is coming out to be 85%. So what I shall infer from this, what I shall conclude from this, that is 85% of the entire distribution within the data set is less than 11. I think this proves the concept right over here. And now I shall be moving on to find out various other percentile concepts. Let's find out. What value exists at percentile ranking of 25%. Fine. And also what value exists at 75 percentile. We need to find out these two data basically from the data set, that which element within the data set is at 25 percentile and which is at 75 percentile. How should we find out? So for this we do require our data set. So I am rewriting it because we don't I have deleted it previously. So 2 2 3 4 5 5 5 6 7, and then we have 8 8 8 8 and 8, that is 5 times 8, and then 9 comma 9 and 10 11 11, and then it's 12. So on counting it would come out to be n is equals to 20, and we are supposed to find out what? We are supposed to find out the 25th percentile and 75th percentile. So for this I need to write down a formula, that is index position. Index means the face value, the face position of that particular number. Index position of value. Okay, this is equals to percentile divided by 100 into n plus 1. So here we have n is equals to 20, and for percentile is equals to 25%. What we can write it down as 25 by 100 into 21, which comes out to be how much? 525. Basically 25 into 20 comes out to be 500, and plus 25 it comes out to be 525, but because of 100 there will be a point of digit, so 5.25. okay, so 5.25 is the index position. So where do it comes out, we will see it later. And then if for percentile 75, basically for percentile 75, how do we find out? So the same formula, 75 by 100 into 21. Fine. So it comes out to be 63 by 4, which is equals to 15.75. So in this case index position IP was 5.25, and here index position is 15.75. Fine. So how do we conclude that what is, because this is in fraction value, this is also in fraction value, and this 5.25 means, let's see on the data set, 1 2 3 4 5. So it is greater than 5 and it is coming out to be 5.25. so anywhere between here, between this 5 and this 5. And again we are also having the, for the 75th percentile from left hand side, particularly index position has come out to be 15.75. so here up till here was 5, then 6 7 8 9 10 11 12 13 14 15. So 15.75 means anywhere between 9 and 9, so somewhere between these two data. So how do I conclude that which is the value for this index position? So for this, for the 25th percentile, it comes out to be 5 within between 5 and 5, and also for 75th it is between 9 and 9. So for finding out the value for those part, we need to calculate the mean value. So mean value would be 5 plus 5, since these two data are same, so it would come out to be 5 plus 5 plus 2, that is 10 by 2, and it would come out to be 5. So that means 5 is the value of 25th percentile. 5 is the value of 25th percentile. Okay, likewise for the 75th percentile, what we will have? 75th percentile, it would come out to be 9 plus 9 by 2, that is 18 by 2, it would come out to be 9. So for 75th percentile it would come out to be 9. So I think I have made it quite clear. Please memorize the data. I will be using it for the later part also. Please take a screenshot if required. So now we'll come into inter quartile range calculations. So visually we will see it later off on the box plot, how we are using it, and we may also get an overview using Python or in various other data sets. We'll be using a data set in Python and we'll be finding out that would be a remaining on the next part that we will be doing. But presently, if I do it theoretically, how do I find it out here? Practical part will be done later off. See, 25th percentile, what do we understand by this? We have written it down that 25% of the data lies below the value. This 25th percentile is also termed as first quartile. We know that in a year there are 12 months, and if we say quarter of an year, it corresponds to 12 divided by 4, so which comes out to be 3, therefore 3 months. So each 3 months we have a quarter ending. So similarly, if we consider 100 as a percentage in total, and if we divide it if we divide it as by 4, then it comes out to be 25. Therefore this every 25 percentage within that would be considered as a percentile value, as a quartile value. So first 25th is considered to be as 25 first quartile. Since it is percentile, we refer to as first quartile, and it is also termed as lower quartile. Why this is lower quartile? We will see it also in while visualization in box plot. It will be very much clear. And similarly, 75th percentile, this, how do we refer to this? It is that 75% of data lies below the value which we have got, and it is termed as third quartile or upper quartile. Fine, I guess we are into it. And like previously in our data set, what we have got, that 25% of the data lies below the value of how much? That was 5. And 75% of the data lied below the value of how much? It was 9 in our data set, which had 20 samples, 20 elements into it in the data set. So if we draw this line, we have this to be minimum value, this to be maximum value, this somewhere in between comes out to be half of it. So this is basically median, and if it is normally distributed, so it might come out to be that mean is equals to median. And in between this half, we also have a 25th and a 75th quartile. That is this is the lower quartile, and this is the upper quartile. This is 75th percentile, this is 25th percentile, and this is basically 50th percentile, but we refer to as a specific name that we call it as a median. And therefore we may write it also here that median is equals to the second quartile. So this is first quartile, this is second quartile, this is third quartile, and this is the maximum value as the highest value, and this is basically the minimum value. So I think this is completely visible on box plot. What we get, I am drawing it right over here. We do have this as a median value, we have an upper limit, we also do have a lower limit, and thereby in between we will be having that percentiles of 25th and 75th. So this we will be seeing it on the box plot while we will be doing it. Take a screenshot of this if required, I guess. Next up we will be moving in into a pedagogy which we will be following, which has been followed previously and is still being followed by an Harvard University. We will be taking a data set containing 5 numbers, and we will deep dive into each of these central tendency as well as particular data set which will be having as percentiles calculation. We will be having another two which things which I have left it out, that is variance calculation and standard deviation. We will be directly doing it in that example only, and we will be concluding various things which will be required for as an inference for the next step that we will follow.